not this voltage. Not this voltage. Not this. This current is V in minus V out over times 1 over Gm, which is this current. V minus V out over 1 over Gm is this current. This current equivalent to this current. This resistance equivalently produces the resistance. This times this is going to this voltage. What? That's a little bit weird. By definition, the Thevenin Norton equivalence definition is not totally equal the same as this. It's tricky. In this case, in this kind of case, using Thevenin equivalent is just so complicated. But we can use this transformation. We get some very useful, easy derivation method. But I don't know anytime. Actually, and why? So why the teacher use this equivalence? The reason why is the bottom of this page 72 or 72. If there's some load resistance V out, capital RL, we need exchange this GMB, some kind of equivalent, R equivalent. So just voltage divider considering RL committed. Source follow. This is common source. We are discussing source follower. If source follower win bias RL and VDD, and this is V out. RL load is source follower. Voltage gain is derived from this Thevenin equivalent easily. So why? This takes use this derivation at first. Is the reason is this case. We can use this for this loading condition. But this is exactly correct from this Ohm's law. But this insight derived this Thevenin current to voltage Thevenin equivalent. But in a usual sense, just a little bit complicated and not easy acceptable. I'm not so feel confident for this derivation saying as Thevenin equivalent. But the formation is Thevenin equivalent, so Thevenin Norton, but no, this being is must be usually R out times GM V1 times GMV1. 1 over GM times GMV1, and this is V1. Or this is V in minus V out. This is opened. but this is V out. And this is current loaded. In loaded cases, we need this. So maybe my less knowledge making myself complicated, but usual Thevenin equivalent IR, this is output node, and VR, this is output node, and IR equals V, or I equals V over I, V over R, V over I, IR, V. But when it's loaded, something this is this equivalent, or IR. We need write VI curve, and so we need enhance Thevenin-Norton equivalence understanding next time, or this time, or as possible, as first as possible, ASAP. We need to enhance the understanding of Thevenin-Norton equivalence in loading case, and applying some cases to deeply understand or easily derive from this to this, and easily applying this formation from this to this application. So V in minus V out equals this V1, and this current is flowing through this current, this same current flowing through, interestingly, looking into resistance, looking into the source, which is 1 over Gm. But this representation is simply almost whole row leads to the same result for AV voltage gain. So there's no complement for this derivation, but simple understanding of fundamentally simple understanding of Thevenin-Norton equivalent doesn't work enough for this situation, or my understanding less. I'm trained less. I need much more training for Thevenin equivalent, or more sense. Just a little bit, just a few examples. We must get more sensible, or understanding for Thevenin-Norton, and utilization of this application, on the application of the usage of this case, like these application. Watching like this, we derive like this, and watching this, neglect neglect loading, and like this derivation simply applicable loading model and actual loading case using this simple equivalence is the very effective way to derive the less calculation needed and introduce less less human error. Introducing less human error equivalent representation and application is the point for analog understanding, analog circuit understanding. Some people say, I know, I remember some teachers said or wrote in their homepage or textbook, just like that. Effective representation expression is very useful and mandate for getting analog insight. Analog circuit designer must be capable of utilizing the effective expression like this, Thevenin equivalence, Norton equivalence, for less easy circuit to more difficult application. So I feel I'm not so much confident, but I feel comfortable of this understanding of importance of effective thought using equivalent circuit for analog circuit design. Knowing this theme, like this derivation, we need to understand, utilize Thevenin method, mandate, and expanding the idea, utilize these effective thought is getting at the speed. It speeds you. Speed is a key for any soldier, any designers. Speed is a key. So effectiveness is a key. Calculating too much formula is reading errors for human being, and we got more probability to die, but vice versa. Less load, less complicated, less complexity makes us give us more probability to live longer, to survive. So soldier and an engineer to survive effective thought is mandate, I think, but I forgot many times because of the funness. It's fun to derive using calculation from formula to formula, but making errors and correcting many times and finally get to correct one is we got feel comfortable of that action, but it took very long time. If enemies attacked, we must die along the way to calculate and making a mistake and correcting. It's not good for survival. To survive, why is very interesting. Next time, I'd like to restudy the input refers noise, thermal noise for these two amplifiers, common source and source forward, using AV output voltage, output over input voltage ratio, voltage gain AV. But alongside this theme, I need to enhance the understanding, and I need more effective understanding, and we need effective thought correctly and promptly for relevant cases to survive, to get more probability not to die along the way of our calculation. Less calculation or first calculation and correct calculation is Monday.